Hello everyone, and welcome to this mathematical ramblings video. Today we're going to be having a look at something called continued fractions. And these actually have a lot of use cases. For example, in finding approximations for something like square root of 2 or square root of 5, you could use continued fractions to find a good approximation for them fractionally. But just to start off with, I thought it might be good to go over some basic definitions for fractions which will apply a bit later on with continued fractions. So, for example, a fraction like 11 over 3 is known as an improper fraction and also sometimes a top-heavy fraction, and that's because the numerator is larger than the denominator. Then a fraction like 4 over 5 is sort of the opposite, you can probably tell. It's known as a proper fraction, and that's because the numerator is less than the denominator, so 4 is less than 5. And then with these improper fractions, so like with 11 over 3, for example, what we can actually do is write them as a mixed number. So continuing with 11 over 3, we can write this as 3 and 2/3. And with these mixed numbers, the main thing is that the integer in front is the largest it can possibly be, so that the fraction after is proper. Basically, you couldn't have, for example, 2 and 5/3. That's not considered a mixed number. And now actually we can actually go on to see what continued fraction is, and it follows in a bit from mixed numbers. So continuing again with our example of 11 over 3, we can write 11 over 3 as we just did as 3 plus 2/3. And you might notice here I've actually put in the plus explicitly rather than implicitly, which is because effectively there is a plus between the 3 and 2/3 when you write it, but you just don't write it to save space. But anyway, I'm going to write it explicitly, and you'll see why in the next step. So what we're going to do is replace that 2/3 with 1 over 3 over 2. And this is exactly the same expression still. You've just flipped the fraction and then done 1 over that, which effectively flips it. Again, basically it's exactly the same expression, just in a different format. But what this format allows us to do is if you look at the denominator of this fraction, so that's 3 over 2 here, that's actually another improper fraction. And because of that, it means we can write it as a mixed number in itself. So we can replace that 3 over 2 with a 1 and 1 over 2. And you can sort of see a little bit now maybe why it's called a continued fraction, because you have a sort of continuous series of fractions. But it's actually not that long in this case. In this case, it actually terminates now. It doesn't keep going on. Now, there are actually some cases where it does, and I'll look more at that in the next video about this. But for now, I'll just say that for any rational number, so basically a fraction or an integer, this continued fraction will terminate. And the reason it terminates is because we have this 1 on the numerator here. And you're wondering, what's significant about the 1? Well, with this step here where we've changed 2 over 3 to 1 over 3 over 2, we sort of did 1 over the reciprocal of the fraction, so it's overall the same. If you try to do that with 1/2, what's going to happen is we start with a half, and this is going to go to 1 over 2 over 1. Problem is, we have 1 in the denominator, that just goes, and so we're still left with a half. Effectively, we can't actually split out any further. So whenever we have that 1 on the numerator, that's when the continued fraction will terminate. I'll just go through another quick example just to clarify things, I suppose. And that example is 31 over 14, and this is a slightly longer continued fraction. So we can write this as 2 and 3/14. You can check that yourself if you want to. And then, as with before, the next step, we do 1 over the reciprocal. So 1 over 14 over 3, we're just flipping it. We then write 14 over 3 itself. Because it's an improper fraction, we can write it now as a mixed number. And we can fit 4 plus 2/3 for that. And then with our next step, we continue again. You may notice we actually have 2/3 again. We had that here. So it is going to end up being the same, but I'll just go through the full process just so it's clear. So we're going to have 2 plus 1 over 4 plus 1 over 3 over 2. So you do end up with quite a few sort of nested fractions. And next, we can replace, as we did before, that 3 over 2 with 1 plus 1 over 2. And then again, the important thing is we got this. The important thing is we got this 1 on top, and that means that we must now, it now terminates. We can't continue this continued fraction, I suppose you could say. And yeah, that's it for this video. Next time, I'm going to be having a look at more stuff with continued fractions. Today, all we looked at is some fairly simple fractions, as in converting a fraction into another continued fraction. But you can do it for irrational numbers too. So for example, you can write square root 2 as an infinite continued fraction, or square root 5, or any other square root for that matter. And even you can do it for cube root 2, and somewhat, it's not technically a continued fraction. There's also something similar for pi as well. So we'll have a link at stuff like that next video. I hope you enjoyed this one in a slightly shorter format. And I'll see you guys in the next one. Please like, comment, and subscribe. And any feedback is greatly appreciated. Thank you.